Lesson 2C is percent of error. It's really similar to what we learned yesterday, but it's different. So just be really careful in reading the directions in the word problems, what it's asking you to find. So we're finding percent of error. Yesterday was percent of change, how much it changed between two numbers. Today is percent of error, so how much you are off by. Okay? So starting with background knowledge, which is, like I just said, what we learned yesterday. Percent of change was the ratio of change to original. And then today, percent of error is the ratio of amount of change to actual. So the difference is the bottom number. Today is going to be using the actual amount. So your proportion looks like this. It looks almost the same, except the bottom number is the actual amount instead of the original amount. So you have to read carefully in the story problem which one is actual, okay? So you can also think of it as percent over 100, which since we're finding percent, we don't know what it is, so we use a variable, and then part over whole. The part is going to be the absolute value, please write this down, with these vertical bars, absolute value of your amount subtracted by the actual amount. And then the whole is the actual. So yesterday was big minus small. Today is your amount minus actual amount, and then absolute value it, because we don't need any of those negative numbers. Okay. Alright, so let's go over that example, which is on your notes. You need to purchase a new countertop for your kitchen. You estimate that the top has a length of 5 feet. You're guessing that it's 5 feet long. But when you actually measure it, it's 4 feet long. What is the percent of error? So you were off by some feet, right? And I want to know the percentage you were off by. So we're going to use this proportion. Go ahead and write it down for the example. N over 100 equals amount of change over actual. What is the actual amount in the word problem? Jaden? The actual amount. Look for the word actual or something that means the same thing. 4 feet. 4 feet. The actual amount is 4 feet. It's actually exactly this sentence right here. So that 4 feet is going to be your bottom number. So n over 100, this is what we're looking for. And then change, how much did it change from 5 to 4? You're 1 foot off, so that would be the top number. And the actual is 4. Then you're going to solve this proportion, just like we did practice yesterday. 4 times what is 100? 25. 1 times 25 is 25. So this is 25% error. 25% error. You are off or wrong by 25%. Okay? Let's do number 1 together. Sam estimates that the Bullseye store will receive 100 stereos during their next shipment. If Bullseye actually receives 125 stereos, how much was Sam percent of error? So same proportion that we've been practicing, except the bottom number is now actual amount. N over 100 equals, what's the amount of change? 25. He was off by 25 stereos. And then the bottom number is actual amount. How many stereos was actually received? 125. Be careful, because if you use 100, now your answer is going to be wrong. Be really careful which number you're plugging into your setup, okay? Really, really careful. So 25 over 125, you can reduce this. Divide by 5, or you can just solve it, whichever one you are used to doing, but I always recommend reducing it first. What's the percentage? 20% error. 20% error. Okay? Go ahead and do number 2 on your own. Michael expects to receive $60 as a birthday gift, but he received $90. What was Michael's percentage of error? Can I have Nylea set up the proportion for us, please?
I put x over 100 equals 30 over 90.
30 over 90? Good. That is correct. 30 because the difference of 90 and 60, between 90 and 60 is 30. And then he actually received $90. Now the word actual was not in the word problem this time, but you can figure that out just by reading the sentence, right? It says, but he received $90. So that would be your actual. Then you can divide top and bottom by 30, or by 10 and then by 3. Or not reduce at all, but I recommend that you do. Kara, what was your answer? N equals 33 1/3%, or you can have this as a decimal, 33.3 with a bar on top %. You have to have the bar on top if you want to use a decimal. Otherwise, 33.3 without the bar, that would be 33 3/10. That's a different fraction. Okay? Who got this one right? Awesome. Number 3. Excuse me. At 6 a.m., there were 50 people who turned up for a job interview. By 8 o'clock, there were 80 people. What was the percent of change? I'm going to read that question again. What was the percent of change? Was there something that somebody made an error in this problem? Did somebody guess wrong on something? No. What's the question asking for? Percent of change. Is that not what we learned yesterday? So go ahead and do this problem, but this is what we learned yesterday, and I threw this in here because I want you to be really careful reading the directions, because on your homework, on your test, it's going to be all mixed up, and you need to read the problem carefully and see what it's asking of you. Even if you tried to do percent of error, it wouldn't make sense. There's no error made in this problem. It's just a change that happened. There's 50 people, then there's 80 people. It wasn't somebody guessing incorrectly. You should have set this up as n over 100 equals change, which is 30, over the original amount, which we started out at 6 o'clock in the morning with 50 people. And then you should get 60%. And there was more people, so this would be an increase. Increase. Okay? There are 4 more problems on your notes. I want you to work with your partner quietly and finish all 4 of those, but be really careful what the question is asking of you. I mixed it up in there. Okay? Go ahead. Ready? Share.
Okay.
Number 4, as I was walking around, I saw a lot of you guys, some of you still insist on doing decimals, even though I told you fractions are a lot easier. And for this particular problem, you found that if you try to do decimals, you're going to stay there for a long time. Like, a long time. Right? So, this was finding the percent of error, so the bottom number has to be actual. N over 100 equals the change, and 120 minus 65 is 55. And what was the actual amount? How much did that bike cost? $65. So you can reduce that ratio before you solve or not, but I recommend that you do. And get 11 over 13. Then n equals 84 8/13%. If you try to do it as a decimal, it's going to go on for quite a while, and you're just going to sit there and not finish any other problem for the rest of the day. Right? If you do fractions, mixed numbers are the best way to go, because once you get a remainder, you're done. Just put that remainder at the top of your fraction. You don't have to add zeros, keep dividing and dividing and dividing and dividing and dividing. Once you get your first remainder, you are done. So much faster, so much easier, no crazy business, right? So try to get away from the decimals. Fractions are faster, more accurate. You don't have to keep dividing. Just do mixed numbers. Okay? I put this problem in there to show you that fractions are better. Sometimes they don't stop, so you want to do fractions. Number 5, Ken estimated and consumed 2,200 calories per day instead of his normal 2,500 calories per day until his next visit with the trainer. What was his percent of change? Are we finding error? Did he guess something wrong? No, this one is just the difference between the two numbers. How much did it change by? So, Kara, go ahead and do this one for us.
Okay. Is n over 100 equals 300 over 2,500? Side and side, so it's going to be 30,000 over 2,500. So then we do 2,500 goes into 30,000, and you're going to get 12% of change.
Very nice. This is his normal, was that keyword there. Usually his original amount of calories was 2,500. So that's the bottom number, not the 2,200. Just because it came first in the sentence doesn't mean that's the first number. That's why I keep saying starting number or original number, not just the first number. Okay? So very good. This was a 12% decrease. He consumed less than usual. Alrighty, number 6. Mrs. Moore's students in science class were supposed to weigh a 300-gram mass, but Tina thought that the mass was 328 grams. Was she off? Yeah, she was off. She was a little bit wrong, right? So that's why I want a percent of error, not a percent of change. Nothing changed here. That gram, that heavy weight thing, is still exactly the same. It didn't change. It didn't go on a diet or anything, right? She just guessed wrong. So it's a percent of error. So n over 100 equals, what's the difference here? How much was she off by? 28 grams. How much was it actually? 300. So careful, the bottom number was not 328. It's how much the real amount was. And you should get n equals 9 1/3%. If you still insisted on doing decimals, this would be 9.3 bar percent. But remember, you learned your lesson in number 4, right? Don't use decimals. Okay? Number 7. The vet weighed Oliver's new puppy Buster on a defective scale. That scale is not working properly. Okay? On that defective scale, he weighed 43 pounds. However, Buster actually weighs exactly 45 pounds. What's the percent of error? Andrew, can you set up the proportion for us? Just the setup. Amount of change. How much was it different by? Over how much was he actually? Perfect. Go ahead and solve this one. 4 4/9% is correct. Raise your hand if you got that. Awesome. Good job. Good job. All right. Any questions? So we learned today that you need to use what instead of what? Fractions instead of decimals. You also learned that you need to be careful when reading because sometimes they ask for percent of change. Sometimes they ask for percent of error. Depends on the problem. Even if you read the story, the word problem, it would make sense that it's an error or a change, right? Don't just go on autopilot and just start throwing numbers into your proportions. So, number 2 is, what'd you learn today? Ready? Share.